Acids and bases. Calculations for strong acids and bases. In this video, we will learn how to calculate the pH of strong acids and bases by starting with the concentration of the acid or base. As we learned in last video, we need to have the concentration of H+ or OH- in order to calculate pH. In strong acids and bases, because we can make the assumption that they ionize completely, this calculation is made much simpler. As a quick, simple example, if we have 1 molar of HCl, all of it will be converted into H+ and Cl-, leaving us with 1 molar H+ and 1 molar of Cl-. We don't need to do anything with the Cl- because it's simply a spectator ion, but the H+ gives us a way to calculate pH. Let's do a slightly more complicated example and fully extend it to calculate the pH and pOH. It is usually best to start by writing out the equation. Perhaps later, after practice, you'll be able to skip this step, but it is recommended at first. Since it's a strong acid, it will ionize completely, so we will use the right arrow and split it into H+ and Br-. Now we can decide on the concentration of either H+ or OH-, whichever is simpler, based on the idea that the acid ionizes completely. Since we have 0.25 molar of HBr to begin with, and all of it is converted into H+ and Br-, we will end up with 0.25 molar H+ and 0.25 molar Br-. We don't need to do anything with the Br- since it's not affecting the pH, but we do need to use the 0.25 molar H+. From here, we will take the negative log of the H+ concentration, giving us pH of 0.6. This makes sense because it's lower than 7 and we added an acid in. Since I also asked you to calculate pOH as well, we need to subtract pH from 14 to get pOH. We know this because, as we learned in the previous video, pH plus pOH is equal to 14, leaving us with a pOH of 13.4. Let's do the same thing, this time with a base. I've only asked you to calculate the pH this time. However, as we'll see, it's easiest to calculate the pOH first and then to convert that into pH. We'll start out the same way. Let's write the equation. We have NaOH, which we know is a strong base, going to Na+ and OH-. Since it is a strong base, we will use a right arrow. Now let's think about how this affects the concentration of H+ or OH-. Since all of the 0.1 molar is turned into products, it means that we will end up with 0.10 molar of Na+ and OH-. We'll use the concentration of OH- to calculate the pOH by using pOH equals negative log of OH-, giving us a pOH of 1. From here, we can use pH equals 14 minus the pOH to get a pH of 13. Since we added a base and the pH is basic, this is a logical pH. Let's do one last example with a base made from the group 2 cations. In order to balance the charges, calcium hydroxide must have 2 hydroxides for every calcium ion. When we write this out in the equation form, we need to account for that by adding a 2 in front of the OH-. Since we started with 0.001 molar of the CaOH2, when it breaks up, there will be 0.001 molar of the calcium cation, which we won't be doing anything with. But when we look at the OH-, we need to consider that for every calcium hydroxide, there are 2 hydroxides. This means that we have 0.00200 molar hydroxide, not simply the 0.001. Once we have this concentration, the following steps are the same as the previous example. We will take the negative log of the hydroxide ion to find pOH, and then subtract that from 14 to get the pH. Now that you've watched this video, you hopefully have a better understanding of how to use the concentration of a strong acid or base to calculate the pH and pOH. We'll see in later videos that this process is greatly complicated when using weak acids and bases, so please only use this method for strong acids and bases.